All right, so covalent bonding. Plants absorb water through the roots from soil or from a solution containing nutrients. Carbon dioxide from the air enters the plants through small openings in their leaves. The plants use the energy from sunlight to convert water and carbon dioxide into a sugar. How are atoms held together in a covalent bond? The attractions between the shared electrons and the protons in each nucleus hold the atoms together in a covalent bond. A covalent bond is a chemical bond in which atoms share a pair of valence electrons. Remember, ionic is transfer, covalent is share. So sharing electrons. A hydrogen atom has one electron. If it had two electrons, it would have the same electron configuration as a helium atom, which makes it happy. Two hydrogen atoms can achieve a stable electron configuration by sharing their electrons and forming a covalent bond. When two atoms share one pair of electrons, the bond is called a single bond. There are several ways to show a covalent bond. In an electron dot model, the bond is shown by a pair of dots in the space between the symbols for the hydrogen atoms. In a structural formula, the pair of dots is replaced by a line. The electron cloud and the space-filling models show that orbitals of atoms overlap when a covalent bond forms. This shows the four ways that you can see that. So there's the dot diagram, there's the structural formula, there's the space-filling model, and of course the electron cloud model. As a space shuttle lifts off, it leaves a water vapor trail. A reaction of hydrogen and oxygen produces the water. Molecules. Two hydrogen atoms bind together, form a unit called a molecule. A molecule is a neutral group of atoms that are joined together by one or more covalent bonds. The hydrogen molecule is neutral because it contains two protons, one from each atom, and two electrons, one from each atom. A chemical formula can be used to describe the molecules of an element as well as a compound. The element hydrogen has the chemical formula H2. Many nonmetallic elements exist as diatomic molecules. Diatomic means two atoms. Fluorine, nitrogen, chlorine, bromine, and iodine are just a few of those that do that. Multiple covalent bonds. When two atoms share three pairs of electrons, the bond is called a triple bond. When two atoms share two pairs of electrons, the bond is called a double bond. Nitrogen has 5 valence electrons. When the atoms in a nitrogen molecule share three pairs of electrons, each atom has 8 valence electrons. Each pair of shared electrons is represented by a long dash in the structural formula N here. So the three lines mean triple bond. What happens when atoms don't share electrons equally? What factors determine whether a molecule is polar? When atoms form a polar covalent bond, the atom with the greater attraction for electrons has a partial negative charge. The other atom has a partial positive charge. The type of atoms in a molecule and its shape are factors that determine whether a molecule is polar or nonpolar. Except for noble gases, elements on the right side of the periodic table tend to have a greater attraction for electrons than elements on the left. Elements on the top of a group tend to have a greater attraction for electrons than elements at the bottom of a group. Polar covalent bonds. In a molecule of an element, the atoms that form covalent bonds have the same ability to attract an electron. Shared electrons are attracted equally to the nuclei of both atoms. In a molecule of a compound, electrons may not be shared unequally. A covalent compound forms when a hydrogen reacts with chlorine. A chlorine atom has a greater attraction for electrons than a hydrogen atom does. In a hydrogen chloride molecule, the shared electrons spend more time near the chlorine atom than near the hydrogen atom. A covalent bond in which electrons are not shared equally is called a polar covalent bond. Shared electrons in hydrogen chloride molecules spend less time near the hydrogen and more near the chlorine. Can you assume that a molecule that contains a polar covalent bond is polar? When a molecule has two atoms, it will be polar. When molecules have more than one atom, has more than two atoms, the answer is not obvious. In a carbon dioxide molecule, the polar bonds between the carbon atom and the oxygen cancel out because the molecule is linear. In water molecule, the polar bonds between the hydrogen and oxygen do not cancel out because the molecule is bent. So the shape does determine how electrons are shared. In carbon dioxide, there are double bonds between each oxygen atom and the central carbon atom. Oxygen has a greater attraction for electrons than carbon, so each double bond is polar. The carbon-oxygen double bonds are directly opposite each other. The pulls on the electrons from opposite directions are equal. The pulls cancel out, and the molecule as a whole is nonpolar. In a water molecule, there are two single bonds between oxygen and hydrogen. The bonds are polar because oxygen has a greater attraction for electrons than hydrogen. The Walter molecule is bent. The polar bonds do not cancel. The oxygen side of the molecule has a partial negative charge. The hydrogen side has a partial positive charge. How do attractions between polar molecules compare to attractions between nonpolar molecules? Attractions between polar molecules are stronger than attractions between nonpolar molecules. In a molecular compound, there are forces of attraction between molecules. These attractions are not as strong chemical bonds, but they are strong enough to hold molecules together in a liquid or solid. Water molecules are similar in mass to methane, yet methane boils at negative degrees Celsius, while water has to go all the way up to 100 degrees Celsius, because methane molecules are nonpolar and water molecules are polar. Dashed lines represent attractions between partially positive hydrogen atoms and partially negative oxygen atoms. These symbols show, so this part of hydrogen is attracted to that oxygen and so forth. And this is what allows water to kind of be attracted to each other and boil at a higher point. So these attractions among nonpolar molecules are weaker than attractions among polar molecules, but they do exist. Attractions among nonpolar molecules explain why carbon dioxide can exist as dry ice and why nitrogen can be stored as a liquid at low temperatures and high pressures.